Defending against AI weaponized cyber attacks requires an auditable, open-source AI agent harness running refusal-free local models to shift security into the developer's inner loop. Right now, attackers are already deploying autonomous AI agents to continuously probe networks, write custom exploit payloads, and discover zero-day vulnerabilities at massive scale. Meanwhile, engineering teams are largely stuck relying on manual security audits, penetration tests, and static analysis checks that happen far too late in the deployment cycle, usually in staging or production. The practical result of this mismatch is asymmetric leverage. Defenders are operating with high latency, while AI-driven attackers are operating instantly. To close that gap, defenders need to deploy their own autonomous agents. But doing this securely requires us to deconstruct how an agent is actually built. The core architectural formula for the OpenWorker framework is simple. An agent is a model plus a harness. The model is the intelligence engine, reasoning through code and matching vulnerability patterns. The harness is the execution layer, managing file access, terminal subprocesses, and network boundaries. You cannot achieve autonomous, secure cyber defense without independently securing, auditing, and owning both of these distinct layers. This visual illustrates how OpenWorker applies this theoretical architecture to practical workflows. It embeds 3 specialized autonomous security personas directly into the codebase. The first node is the Code Vulnerability Scanner. This persona handles static application security testing, using abstract syntax tree analysis to hunt for logic flaws and OWASP top 10 vulnerabilities, like SQL injection or cross-site scripting. The second is the Dependency and Supply Chain Auditor. It actively parses log files to detect malicious packages, compromise transitive dependencies, and typo-squatting injections before they install. The third is the Cloud Posture Checker. It scans infrastructure as code templates like Terraform, Kubernetes, and Docker manifests, identifying exposed attack surfaces and overly permissive access configurations. By dividing the labor among these 3 specialized subworkers, the system continuously and autonomously audits the entire application attack surface. But if we want to deploy this system inside an enterprise, we hit an immediate operational roadblock at the model layer. As this contrast card shows, commercial APIs like GPT-4o routinely refuse to analyze exploit proofs of concept. And as seen on the left, sending proprietary code to external servers violates privacy. Moving to the right side, OpenWorker runs local open-weight models completely air-gapped on your laptop. Running these local models guarantees 0 safety refusals on exploit analysis, incurs exactly 0 API token costs, and ensures absolute air-gapped code privacy. That solves the model, but we still have to address the second half of the architectural formula, the harness. Because even with a perfectly secure local model, the harness is the software that actually executes terminal commands and controls network egress. An enterprise security team cannot deploy a closed-source, black box agent harness like the one represented here. A closed execution environment is a massive, unverified attack vector inside your own network. OpenWorker resolves this with an execution layer that is 100% open source. Security engineers can inspect every single line of the back-end code. This total transparency guarantees the complete absence of telemetry backdoors, data exfiltration hooks, or hidden call homes to external entities. When you combine refusal-free local models with a fully auditable open-source harness, you reach a new operational equilibrium. Notice this deployment timeline. We call this shift-left autonomous security. Vulnerabilities are now actively hunted, analyzed, and patched directly in the developer's local inner loop, long before the code ever reaches staging or production. To summarize our core requirements, first, local models are strictly required to ensure absolute code privacy and refusal-free exploit testing. Second, open-source harnesses are mandatory to guarantee 0 data exfiltration and to establish verifiable execution boundaries. And third, this unified architecture shifts autonomous defense entirely to the left, providing defenders with the computational leverage required to outpace automated threats.